Welcome back to the Explainer. So, if you're with us for lesson 1.3.2-V2, you know we lay down the foundational criteria for zonal division, the idea of organizing a site based on how often we visit different elements. But today, we're going to elevate that understanding. We're taking that theoretical model straight out of the classroom and dropping it right into the rugged, uneven, and honestly fascinating reality of the physical world, so we can look at how real landscapes actually shape our designs.
Now here's where reality completely shatters a really common misconception. You know that perfect, pristine bullseye we usually see when learning about permaculture zones? Those neat concentric circles radiating outward? Well, compare that theoretical target map with reality and things look wildly different. In the real world, zones aren't rigid rings. They're actually more like highly adaptable elastic bands that stretch and warp depending on the environment around them.
So here's our roadmap for today. We're going to move beyond the concentric myth, take a look at Mollison's golden rule, and then dive into the scale of permanence. After that, we'll analyze how bending zones with axis in topography actually act as active forces of zonal deformation.
All right, part one, beyond the concentric myth. Let's start by moving beyond those neat theoretical circles and observing how a site's natural characteristics totally disrupt that basic geometry.
I want you to picture those crisp circles we studied before, just sort of melting and stretching. Because in reality, zones get warped by everyday things, access roads, steep slopes, and honestly, just where we actually prefer to walk. You see, zones are really, at their core, conceptual, energy-conserving patterns. They aren't strict geographic realities that you can measure out with a ruler. They absolutely depend on the origin of available on-site energy. And in most human-designed systems, that energy source is you. It's human circulation through the space.
Moving on to Section 2, Mollison's Golden Rule. To really analyze how these zones stretch, we first have to understand the human step that kicks off the entire design process.
And this crucial point comes straight from permaculture co-founder Bill Mollison. Think about it. The human element is literally the center of gravity in our system. His golden rule says we need to develop the nearest area first, get it under control, and then expand outwards. Our daily movements radiating from that center, our zone zero, right, are exactly what dictates the shape of that expanding perimeter. We are the energy source. The frequency of our visits is what actually determines the zones.
Okay, Section 3, the scale of permanence. Let's look at how this builds into the physical environment using a brilliant framework originally developed by Australian agricultural designer P.A. Yeomans.
So right here we have Yeomans' keyline scale of permanence. When you look at this hierarchy, imagine a timeline going from deepest time all the way down to human intervention. At the very top, you've got climate and landscape topography. These are incredibly permanent, right? I mean, you're not going to just move a mountain, and you certainly aren't going to change regional rainfall. Because they're so permanent, they force the placement of the more flexible elements further down the list, specifically where we can actually build our roads and access paths.
If we really follow the logic of this scale of permanence, we hit a profound truth about our landscape designs. We can't just slap a path anywhere we feel like it. The unchangeable shape of the land, the hills, the valleys, those rocky outcrops, they strictly dictate where our access roads go. And since access dictates human movement, it's actually the topography that's dictating our zones.
Which brings us to Section 4, bending zones with access. This is the core analysis of our explainer, bringing together Mollison's human circulation with Yeomans' landscape permanence to see what actually happens out there on the ground.
And that gives us zonal deformation. Think of your zones like a giant elastic band. Instead of drawing a perfect circle with a compass, you're taking that elastic band and stretching it along a path you walk all the time, or pulling it down a well-placed road. Zonal deformation is just the reality that zones stretch along paths of least resistance, and they compress real tight the second they hit natural barriers.
Take a look at this house nestled on a hillside. Notice how Zone 1, the area that needs constant daily observation, doesn't form a circle at all. Instead, it stretches way out to the sides, perfectly following a level contour path. And the reason is simple. Walking on a flat contour is the path of least resistance for our circulation. We'll naturally walk 100 feet on flat ground way more often than we'd ever climb 20 feet straight up a steep hill.
And that perfectly sets up our next variable. Check out how this long, stretching Zone 2 reaches way down the ridgeline. Again, why does it do that? Well, according to the scale of permanence, that ridgeline was literally the only logical, stable place to build the primary access road. And because the road is there, humans travel it daily. Wherever human energy flows easily, those intensive use zones get pulled right along with it, stretching that elastic band far away from the house.
All right, final section. Number 5, topography and zonal deformation. So we've seen how zones stretch along roads and contours, but let's analyze what happens when the landscape decides to fight back.
Just visualize a steep, rugged cliff right out the back door. Even though it's physically just a few feet away from the kitchen window, the immense effort, the absolute friction required to climb it, compresses Zone 1 into this tiny, paper-thin sliver. Because you rarely go up there, that nearby slope instantly turns into a distant Zone 3 or Zone 4. The topography is basically acting as a massive compressor against human movement.
Okay, let's look at this final comparison to really lock this concept in. Access roads act like gravity, pulling your elastic zones outward. On the flip side, steep slopes, dense brush, or bogs, they push back, compressing those zones inward. This proves something absolutely vital for any designer. Distance in permaculture is not measured in feet and inches. No, it's measured in energy and time. A flat path 200 feet away might literally cost less energy to visit than a 30-foot scramble up a muddy bank.
So to tie it all together, we use those conceptual circles we learned about previously as our starting baseline. But to create a design that actually survives reality, we absolutely have to analyze the friction of the topography and the fluid flow of those access paths. Mollison gives us our center of energy, Yeomans tells us where the permanent landscape will actually let us move, and zonal deformation, well, that's the beautiful, totally unique, site-specific map you get when you combine the two.
As we wrap up this explainer, I really want to leave you with this thought. Take a moment today to look out your window or just look at the layout of your own neighborhood. Ask yourself, how is the unchangeable landscape, the slopes, the roads, those hidden paths of least resistance, already dictating your every step and deforming the zones of your own daily life? I guarantee, once you see it, you literally cannot unsee it. Thanks so much for joining me on this deep dive, and keep observing those natural patterns.